Amazon has been asking this question for 15 times over the past 6 months. This is Leetcode, longest increasing substring. If we have an array like this, the longest increasing substring will be 2, 3, 7, and 101. Another example will be 0, 1, 2, 3. There are multiple ways to solve this question. Next, I'm going to talk about dynamic programming and building subsequence. Their time complexity is n squared. If we are given an array like this, we can first initialize a DP array with all 1 inside. This DP function actually means the result that we need to return from the longest increasing substring. If we look at this DP individually, we can clearly see that at this point, the longest increasing substring is this subarray. So we can have this DP change to 2. If we're moving to the next DP over here, we can clearly see that 0, it only has itself as a longest increasing substring. As we are moving to the number 3 here, we can see that if we're looking back, we have 0, 1, and 3. This is the longest increasing substring, so we can change this 1 to 3. If we're moving to number 2 here, we can see that this path is the longest increasing substring, 0, 1, 2, so we can change this to 3 as well. In order to solve a dynamic programming problem, there are 3 steps that we need to figure out. The first one is declare the DP function, which we already did. The DP function is the result we want from the longest increasing substring. The second step is to find the relationship. As we are building the DP array, every time we need to look back, so j is going back this index, the maximum of the previous one. The third step is the base case, which we initialize each value in the DP array is 1. It's just simply because each individual value can be considered as one longest increasing substring. This is the Python code. You can see that the first one, we initialize the array with the base case value. We implement the relationship between each DPI for the second step. Finally, we return the maximum value from the DP. We have 2 for loops here, so the sum of the time complexity is actually 1 plus 2 plus 3 until the end. So it's n squared total. Next, I'm going to talk about another approach called building subsequence, which is going to take n squared time. Now, how do we build a subarray? If the current num is greater than any of the elements in the sub, we append the element to the subarray. Otherwise, that means in the subarray, there exists an element that is greater or equal to the num. So we replace the element inside the sub. We initialize the subarray to be the first element of the nums as we are looping through. If we have the nums here, then we append to the sub. If it is 0, then we do nothing. If we have 3, then we append to the sub because it's greater than the maximum. If we have 2, we replace 3 to 2. Finally, if we have 3, we append to the subarray. Please do keep that in mind that in some scenarios, the subarray is not actually the subarray of the longest increasing substring, but the length of the subarray is actually the final answer. And this is the Python code. You can see that the first if statement relates to the first rule we talked about in the algorithm, and the else statement. If you like this channel, please click like and subscribe. Thank you.